Hi, my name is Jack Van Welzen, and I will be discussing the use of laser speckle imaging techniques to detect hidden damage in composite materials. Shown here is an example of a dynamic laser speckle pattern.
Laser speckle patterns form when coherent light reflects off a rough surface and reaches an observer with random phase shifts. The light interferes with itself in such a way that results in a speckle pattern similar to that shown in red below. In many applications, the noise of the speckle is seen as detrimental and is reduced as best as possible. The bottom left images compare image quality before and after speckle reduction. While sometimes a hindrance, the speckle pattern holds information about the surface it's illuminating. As such, imaging techniques such as laser speckle photography have been developed to extract physical properties from the speckle patterns. While the images below look identical, an X was traced on the wall with a finger between the two. Using a correlation algorithm, the similarity map on the right was created to reveal the tampering. Laser speckle photometry and laser speckle contrast imaging also use the speckle pattern to their advantage. In photometry, the specimen is excited, causing the speckle pattern to change rapidly. The nature of these changes is then linked back to the physical properties such as hardness and effectiveness. Laser speckle contrast imaging relates blurred regions of the speckle to areas where there is high fluid flow. The blurriness is quantified as a localized contrast metric. For laser speckle photography and laser speckle photometry, the desired properties are identified using correlation algorithms to compare the test frames to a reference frame. To test our prospective algorithm of structural similarity, or SSIM, we processed images from the crash site of Israel Aerospace Industries lunar lander Beresheet. The crash site was identified much more clearly using our SSIM analysis than in the raw images provided from NASA. Inspired by recent successes with laser speckle imaging techniques, our plan is to apply laser speckle photometry to scan large areas on aircrafts to detect hidden damage in the composite panels. Suppose we look at the aileron of a Boeing C-17 Globemaster III. Using a camera, laser, and excitation source, the aileron's surface can be scanned. Running a correlation algorithm in real time allows for the defective regions to be identified and slated for maintenance.